Hello everyone, I am engineer Ahmed Rabuzi, who last 3 years has worked on many structural design, such as structural design of a villa and many residential buildings. And this course I will teach you CSI, ETABS and SAFE softwares, 2 softwares and 1 course, from beginner to expert. We will take an example of 15 stories residential buildings located in Lebanon. This course is not just a tutorial on software, but it is a complete understanding of how civil engineer must think, how he or she began with the structural design, what he or she will do when receiving an architectural plan from an architect. And this course we pass through all the problems and structural elements that a civil engineer can face, such as all type of slabs, all type of foundation, columns, beams, shear wall, and earthquake design. Now we show the outline of this course. The general titles, we will pass through them in this project. First of all, introduction to structural design. Second, description of the project working on. 3, determination of the dimension of structural elements. 4, introduction to ETABS 2016. 5, ETABS model. 6, earthquake loads, column and shear walls. 7, introduction to SAFE 2016. 8, design of footings. 9, design of slabs and beams. 10, deflection short and long term. Now we will talk what ETABS and SAFE can do. When using ETABS, we can do the structural design of columns, shear walls, earthquake design, and wind design. When using SAFE, we can do the structural design of slabs, beams, foundation, and check the deflection of slabs or footings. Now we will show the structural features of the project working on in this course. First of all, the type of the building working on this project is an residential buildings consist of 15 stories plus 1 basement located in Lebanon. The material using in this project was FRAMC equal 25 megapascal for horizontal element, slabs and beams, FRAMC equals 30 megapascal for vertical element, columns, walls and foundation, FY equal to 420 megapascal for longitudinal reinforcement, FYT equal 240 megapascal for transversal and reinforcement. FRAMC is the compression strength for concrete using in this project, and FY and FYT are the tensile strengths for rebar using in this project. The bearing capacity of soil equals 3 kg per centimeter square. The height of the basement equal to 4 meters. The height of the typical story is equal to 3 meters. We use shear wall system for earthquake design with a coefficient R equal 5.5. And the next section we will show what are the all system for resisting earthquake, why we use shear wall system, what is shear wall system, what is R, and why R equal to 5.5. We continue through to show the structural features of this project. We assume that shear walls, the thickness of shear walls equal to 40 centimeters. Assume that all columns in this project are with minimum dimension equal to 600 by 250 millimeter. And the next sessions we will show how to determine the exact dimension of each type, shear walls and columns. We will use the ACI code for structural design. Now we will begin with the showing you what are the type of slabs we will show and use in this project. First of all, in story 1 and 2 we will use waffle slab. We will talk in the next session why we use waffle slab and when we use waffle slab and what are the difference between story 1 and story 2 and waffle slab. In story 3 we will use ribbed slab. Story 4 we will use flat slab. From story 5 to 16 we use solid slab, and the next session we will talk why we use solid slab, more using solid slab from story 5 to 16. Then we will talk about the advantage of each type of slab, and we will talk how we determine the section of each type of story and the software. We will talk how we determine the section of each slab. Thank you for listening. We will continue our work and the next section. Goodbye.